The scale of feeding an army during World War II wasn't just impressive. It was a logistical miracle that rivaled the production of tanks, aircraft, and ammunition. Every single day, millions of soldiers scattered across Europe, the Pacific, North Africa, and Asia needed sustenance that could survive months of storage, withstand brutal temperature swings, and still provide enough calories to keep a fighting man on his feet. This wasn't a matter of simply packing sandwiches. This was industrial food production, weaponized for war, and the factories that made it possible were some of the most sophisticated operations of the entire conflict. The story begins not in the factory, but in the fields and mines scattered across the American heartland. The raw materials for military rations came from everywhere. So wheat fields in Kansas stretched to the horizon, their golden stalks destined to become hardtack biscuits and flour components. Cattle ranches in Texas provided the beef that would be processed into canned meat. Sugarcane plantations in Louisiana and beet farms in Michigan supplied the sweeteners. Tin mines in Bolivia sent their ore north to be smelted into the cans that would protect all this food. The complexity was staggering. A single sea ration required components from at least a dozen different agricultural and industrial sources, each one needing to arrive at the factory at precisely the right moment. Transportation was its own battlefield. The United States government commandeered entire rail networks to move raw materials. Refrigerated cars carried beef carcasses from Chicago stockyards to processing plants on the East Coast. The grain hoppers rolled out of the Midwest loaded with wheat and corn. Sugar traveled in dedicated cars to prevent contamination. The railway system became a circulatory network for the war effort, and any disruption sent ripples through the entire production chain. Ships brought in tropical items that couldn't be grown domestically. Coffee beans from Brazil, cocoa from West Africa, tea from India. These luxury items weren't luxuries at all in military planning. They were morale boosters, psychological weapons to keep soldiers functioning under impossible stress. Inside the primary processing facilities, raw materials underwent their first transformation. Sugar refineries operated around the clock, their crystallization chambers producing hundreds of tons per day. The process was violent and precise. The raw sugar arrived as sticky brown crystals containing molasses and impurities. Workers fed it into centrifuges that spun at thousands of revolutions per minute, separating out the dark syrup. What remained was refined white sugar, which then traveled to drying rooms where heated air evaporated any remaining moisture. The result had to be bone dry because any water content would cause spoilage in the finished rations. Meat processing plants were theaters of organized chaos. Cattle arrived by the trainload at facilities like the massive complex in Omaha. The slaughter floor was efficient and brutal. Animals moved through chutes where pneumatic bolt guns ended their lives instantly. Skilled butchers worked with knives that needed sharpening every 30 minutes, carving carcasses into primal cuts. The speed was inhuman, so a good team could process an entire cow in under 15 minutes, reducing it from animal to component parts. Blood drained into collection vats for industrial use. Bones went to rendering plants for glue and gelatin. Hides traveled to tanneries. Nothing was wasted because waste was unpatriotic and economically stupid. The meat designated for rations underwent additional processing. Workers trimmed away excess fat because fat could go rancid and ruin an entire batch. What remained was lean muscle tissue, which moved on conveyor systems to grinding rooms. Industrial meat grinders, each one capable of processing 500 pounds per hour, reduced the beef to a uniform consistency. Seasonings came next. Salt acted as a preservative. Black pepper added flavor. Small amounts of sodium nitrite prevented botulism, the deadly toxin that thrived in oxygen-free environments like sealed cans. The mixture had to be precise because too little preservative risked poisoning soldiers, while too much created an inedible chemical taste. Canning operations represented the absolute pinnacle of wartime food technology. The factories that produced military rations operated with assembly line precision, borrowed directly from automotive manufacturing. Picture a facility the size of several football fields, filled with machinery that clanked, hissed, and roared 24 hours a day. The air smelled of cooked meat, hot metal, and industrial lubricant. Steam from cooking vats created a permanent fog near the ceiling. Workers wore rubber aprons and moved with practiced efficiency because stopping the line meant falling behind quota. And falling behind quota meant some unit overseas went hungry. The cans themselves arrived from dedicated tin plating facilities. Steel sheets came in on flatbed trucks, each sheet destined to become dozens of cans. Massive hydraulic presses stamped out the can bodies in a thunderous rhythm. Each strike of the press produced a cylindrical shell, which then traveled to seaming machines that crimped on the bottoms. The noise was incredible, a metallic hammering that required workers to wear cotton stuffed in their ears. The cans moved on conveyor belts to cleaning stations where they were washed with hot alkaline solutions to remove any oil or metal particles. Cleanliness wasn't optional. A single contaminant could introduce bacteria that would multiply in the sealed environment and kill whoever opened the can weeks later. Late filling operations required perfect timing. The meat mixture, already cooked to an internal temperature that killed most bacteria, arrived at filling stations still hot. Workers using specialized scoops portioned exact amounts into each can. The weight had to be consistent because military specifications demanded it. Too little, and soldiers didn't get adequate nutrition. Too much, and you wasted resources. Scales built into the conveyor system automatically rejected any can that fell outside the acceptable range. These rejected cans dumped back into the cooking vats for reprocessing. The sealing process was where chemistry met engineering. Each filled can moved under a seaming head that placed the lid and then rolled the edges together in a double seam. This wasn't just crimping metal. The seal had to be absolutely airtight because even a microscopic gap would allow air inside, and air meant oxidation and bacterial growth. The seaming machines used calibrated rollers that applied precise pressure at specific angles. Technicians constantly monitored the seams, checking them with specialized gauges. A single imperfect seal could compromise an entire production run. After sealing came the retort process, the most critical step in creating shelf-stable canned goods. Retorts were essentially giant pressure cookers, steel cylinders big enough to hold thousands of cans at once. Workers loaded the sealed cans onto racks that slid into the retorts on rails. Once loaded, the massive doors swung shut and locked with wheel mechanisms that required 2 men to operate. Steam flooded the chambers, bringing the temperature up to 240 degrees Fahrenheit. The pressure climbed to over 15 pounds per square inch. This combination of heat and pressure killed every single microorganism inside the cans, including the notoriously heat-resistant spores of Clostridium botulinum. The retort operators were among the most skilled workers in the factory. They monitored temperature gauges and pressure readings constantly, making tiny adjustments to maintain the exact conditions required. Too little heat or pressure and bacteria survived. Too much and the cans could explode, sending shrapnel and boiling contents across the factory floor. The process typically lasted 90 minutes, during which time the operators logged readings every 15 minutes. Government inspectors reviewed these logs daily because human lives depended on getting this right. Cooling happened gradually to prevent thermal shock. If you dropped cans from 240 degrees into cold water, the sudden temperature change could warp the metal and break the seals. Instead, the retorts slowly vented steam while cold water circulated through external pipes, bringing the temperature down over the course of an hour. When the retorts finally opened, workers unloaded cans that were still warm to the touch but safe to handle. Labeling operations added the final identifying marks. Printing presses applied paper labels with waterproof adhesive, or in some cases, the information was printed directly onto the can using industrial ink. Each label included contents, packing date, lot number, and inspection stamps. Oh, this wasn't decoration. The military supply chain depended on being able to track every single can back to its production batch. If soldiers reported illness, investigators could trace the problem to a specific factory, specific shift, and specific lot of raw materials. The variety of rations produced was extensive. The C ration, perhaps the most famous, came in several different menus. M-unit cans contained meat components like beef stew, meat and beans, or ham and lima beans. B-unit cans held bread products, either hardtack biscuits or compressed cereal bars. Accessory packets included cigarettes, matches, chewing gum, toilet paper, and water purification tablets. Each component required its own production line with specialized equipment. The meat and beans line was particularly complex. Workers combined cooked beef with navy beans that had been pre-soaked and parboiled. The sauce was a carefully formulated mixture of tomato paste, sugar, salt, and spices designed to remain stable at any temperature from Arctic cold to tropical heat. Mixing happened in enormous steam-jacketed kettles that held hundreds of gallons. Paddles as tall as a man slowly rotated through the mixture, ensuring even distribution of ingredients. Temperature probes monitored the cooking process because beans required specific heat treatment to break down their starches while maintaining structural integrity. Hardtack production was deceptively simple but required precision. Flour, water, and salt. Mixed in industrial dough blenders until achieving the right consistency. The dough then moved to sheeting machines that rolled it to exact thickness. The cutting dies stamped out the characteristic rectangular biscuits with their grid of holes. These holes weren't decorative. They prevented air pockets that could cause the biscuits to puff up and break during baking. The biscuits traveled through tunnel ovens on wire mesh belts, baking at precisely controlled temperatures until they achieved the rock-hard consistency that allowed them to survive months of rough handling. Chocolate production for D rations involved a completely different set of challenges. The Army wanted chocolate that wouldn't melt in tropical heat, but would still be edible in Arctic cold. Standard chocolate melted at around 86 degrees Fahrenheit, useless in places like North Africa or the Pacific Islands. Hershey developed a specialized formula that incorporated extra cocoa butter and reduced sugar content, by raising the melting point to above 100 degrees. The trade-off was taste. Soldiers universally despised D-ration chocolate, describing it as tasting like sawdust or candle wax. But it didn't melt in their packs, and it provided concentrated calories, so it shipped by the millions. The chocolate factory operated differently from the canning facilities. Cocoa beans arrived already roasted and shelled. Grinding machines reduced them to cocoa mass, a thick paste of cocoa solids and cocoa butter. Additional cocoa butter, sugar, and milk powder mixed in according to the military formula. The mixture went into refiners, machines with rollers that reduced particle size to create smooth texture. Conching machines then worked the chocolate for hours, paddles moving through the warm mass to develop flavor and eliminate moisture. Finally, the chocolate was tempered through careful heating and cooling cycles that encouraged the formation of stable crystal structures. This tempering gave the finished bars their snap and glossy appearance. Molding happened in temperature-controlled rooms. Workers poured tempered chocolate into bar molds, each cavity creating a 3-ounce bar scored into 4 sections. Vibrating tables removed air bubbles. The molds then moved into cooling tunnels where precisely controlled air brought them to solidification temperature. Once firm, the bars ejected from the molds and traveled to wrapping stations where they were sealed in foil and outer paper wrappers. Coffee production for rations represented another technical challenge. Soldiers needed coffee that was instant, requiring no brewing equipment. The process started with regular roasted coffee beans that were ground and percolated to create strong liquid coffee. This coffee then went to spray drying towers, cylindrical structures several stories tall. Atomizers at the top sprayed the hot coffee in a fine mist while heated air blew upward. The tiny droplets dried almost instantly, falling to the bottom as powder. The air temperature, droplet size, and tower height all required precise calibration to produce powder that dissolved readily in hot water but didn't clump in storage. Quality control was relentless and multi-layered. Inspectors prowled the factory floors constantly, pulling random samples for testing. Some cans went to laboratory incubation rooms where they sat at body temperature for weeks. If any showed signs of bulging or gas production, the entire batch was condemned. Now other samples underwent destructive testing. Inspectors opened them, checked temperatures with thermometers, examined appearance, and sometimes tasted the contents. Meat samples went under microscopes to check for parasites. Chemical analysis tested for proper preservative levels. The government stationed military inspectors permanently at major ration factories. These officers had authority to shut down production lines immediately if they observed any deviation from standards. Their presence wasn't symbolic. Production records show numerous instances of entire shifts worth of production being rejected and sent for reprocessing. The stakes were too high to allow any compromise. Packaging for shipment transformed the individual cans into military supplies. Workers assembled rations into complete meal units. A typical case might contain 6 different menus of C rations, ensuring variety for the soldiers who would eat them. The cases themselves were corrugated cardboard, reinforced with metal strapping. Each case was stenciled with contents, packing date, and destination codes. These cases stacked onto wooden pallets that could be moved by forklift and loaded into shipping containers. The warehouse operations were logistics puzzles played with millions of pieces. Rations moved from factories to regional distribution centers, then to ports for overseas shipment. Different theaters of war required different products. The Pacific Theater needed more salt tablets and anti-malarial drugs. The European theater required more cold weather rations with higher fat content. North Africa demanded rations that could withstand extreme heat and sand contamination. Warehouse managers tracked all of this using card filing systems and mechanical calculators, coordinating shipments that would arrive weeks or months later at destinations on the other side of the world. Transport ships carried rations in their holds, stacked floor to ceiling in configurations that maximized space while maintaining stability. Loading operations worked around the clock at ports like San Francisco, New York, and New Orleans. Longshoremen moved pallets with hand trucks and winches, swinging cargo nets full of ration cases into the holds. A single Liberty ship could carry enough rations to feed an entire division for weeks. The ships sailed in convoys, protected by destroyers from submarine attack, because losing a cargo vessel meant losing not just equipment, but the ability to sustain forces in combat. The human cost of this industrial effort rarely appears in historical accounts, but it was significant. Factory workers endured exhausting shifts in hot, dangerous conditions. Accidents happened regularly. Workers lost fingers to stamping machines, suffered burns from steam leaks, developed respiratory problems from flour dust and chemical fumes. The pace never slowed because the war didn't pause for healing. Women made up a large portion of the workforce, filling positions left vacant by men who had shipped overseas. They proved just as capable as their male counterparts, running complex machinery and meeting production quotas that skeptics had claimed impossible. But the factories operated under constant pressure to increase output while maintaining quality. Production numbers from 1943 show some facilities running 3 full shifts 7 days a week, with maintenance squeezed into brief windows between production runs. Breakdowns were emergencies that brought mechanics running with toolboxes to diagnose and repair problems as quickly as possible. Parts often had to be fabricated on site because ordering replacements took too long. The machine shops attached to ration factories buzzed with activity, lathes and mills producing custom pieces to keep the lines moving. By the war's end, American factories had produced over 5 billion individual ration components. The numbers strain comprehension. Enough canned meat to circle the earth if the cans were laid end to end. enough hardtack biscuits to build a pyramid larger than Giza, enough instant coffee to fill an Olympic swimming pool several times over. This industrial achievement kept soldiers fighting across multiple continents and ocean spans, providing the calories and nutrition that made sustained combat operations possible. The technology and processes developed during this period transformed civilian food production after the war. The lessons learned about preservation, packaging, and mass production found their way into supermarkets across America. Canned goods became household staples. Instant coffee conquered breakfast tables. The convenience foods that defined post-war American cuisine owed their existence to techniques perfected under the pressure of feeding millions of soldiers. When standing in one of these factories during full production must have been overwhelming. The mechanical symphony of progress and preservation working in concert to solve one of warfare's oldest problems. The stamping presses sounded their regular rhythm. The steam hissed from retorts. The conveyor belts hummed their endless loops. And through it all moved workers who understood they weren't just making food. They were making victory possible, one can at a time, feeding the arsenal of democracy with the same determination that built the planes, tanks, and ships that carried those rations into battle.